Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Seth's brother, Joel Chaiken. We're here to hopefully show you how to approach SAT math questions. This is from a calculator section, although, frankly, it doesn't look like the calculator is going to help us. Okay, the population of mosquitoes in a swamp over a course of 20 weeks is shown like that. Weeks in population. Which of the following best describes the relationship between time and the estimated population of mosquitoes during the 20 weeks? Linear, up linear, down linear, exponential growth, up exponential, down exponential. So, I don't know, the way I would look at it is it's certainly not linear. When something changes linear, every time...
I'd rather just look at what happens.
Seth,
it goes up by a factor of 10 each time.
Seth, can I finish? Seth,
yeah, well, I think it's more direct.
Okay,
because it's so immediate, the way it's growing.
Yeah, but Seth, you'll have your chance.
Yeah, so why read, it says what column, why not look at, when the property of the number is so immediately obvious.
Yeah,
why bother?
Okay, I'm just doing it in a slightly different way. You're right. Okay, but it's fine. It's fine. So I'm just looking at it. When it goes, what is linear? What is linear? Linear. If it goes from 0 to 5, it goes up, let's say, a certain amount. If it goes from 5 to 10, it should go up the same amount, but it doesn't.
It goes up by adding the same amount.
Adding the same amount. Here it goes up by 900. Here it goes up by 9,000.
Yeah.
Right. No, that's not linear.
Okay. But what's immediate is that each time you get one more zero at the end.
Yeah.
Which means each time it increases by a factor of 10.
Right.
It goes up by multiplying by 10 each time.
Right.
Okay?
But Seth, all I'm saying is that people may be more familiar with what linear is than with what exponential is.
That is the problem with knowledge. People do not understand what exponential growth is.
Right.
Actually, long-term exponential growth is very rare in people's experience.
Right. So
that's why people are so unfamiliar with it.
Right. No. Yeah. Right. All I'm saying is that it may be the default, not an easier way. If you're not that up on exponential growth, because exponential growth is not covered as much as linear growth. This is clearly not linear, and then they gave you the only choice is exponential growth, right? If they gave you a quadratic growth, you would have to think a little more.
Yeah.
You'd have to think a little more. But Seth's right. It's exponential because it's 10 to the n. Right.
Yeah, 10 to the n.
10 to the n.
The n is units of 5 weeks.
N is units of 5 weeks. So 10 to the number of 5 weeks. Okay.
Yeah.
10 to the number of 5 weeks.
So it's 10 to the number of weeks.
Actually, it's 100. It's actually 100.
Number of weeks divided by 5.
Wait. No. Yeah. The answer to the equation is 100 because that's the initial times 10.
Oh, yeah. This is the factor. It goes up. You're absolutely 100.
10 to the up to the power of number of 5-week periods.
Yeah.
Okay, that's really a good way to understand it. So if there's one 5-week period, then it's 100 times 10, which is 1,000. If it's, so the equation is 100 times 10 to the number of 5-week periods, and the number of 5-week periods is the variable.
Well, that's f, 10 to the f.
And so, in the number of 5-week periods is the variable. So it's definitely exponential. There's no question about it. But Seth, you make a really good point about people not really understanding exponential growth because we just lived through this COVID thing. I mean, who knows? Do you think people are going to be watching this video?
Well, I think a lot of people forgot it because in the COVID thing, there was exponential growth only at the very beginning.
Right. Yeah, but people didn't realize that if you didn't really care about getting COVID back then, and you got COVID, that could mean that down the line, a few months later, 7,000 or 8,000 people are going to get COVID because you got COVID. because you
Yeah.
can
Well, I think it was
ultimately
when
get
COVID broke out, it was more like days.
days. Yeah,
You
yeah,
know,
yeah, yeah.
well, we could look it up. But there was one case in the United States that was known actually, and then a few days later there were about 6 cases known, and then another week later it was in the 20s or 30s, and then another week later there were hundreds.
I think the very we started, I was looking at the numbers. I think it was about 30% a day. They went up to
Yeah,
like
30% a day.
went on like
Okay.
1.3, where n were the number of days.
Yeah, right.
So if you 1.3 to the 30, 1.3 up to the 30 in 30 days, however
Yeah.
many cases there were gets multiplied by 3,000. Well, actually,
Yeah.
that's not that much. Actually, um,
I don't know.
that's
Yeah,
actually
well,
not that much.
what's one point? What does that
One
calculate? Say
one
one
point
point
three
three.
to the 30th is only 3,000.
Okay. Did you calculate that?
Now I'm going to do it again. 1.3 up to the 30th power.
Yeah.
Yeah, there's only 3,000.
Yeah. Okay. But yeah. Sure.
3,000, which means that if 5 cases were there, and let's say it's like then that means then a month later you'd have 15,000 cases.
Yeah. Yeah.
In a month, which probably yeah. So
Yeah.
anyway,
Yeah.
but yeah, people don't really understand how powerful exponential growth is. And but my lighting
Yeah.
looks weird. It looks like I have
Yeah.
yeah. So but yeah, Seth, you're right. At some point, it's impossible, and it's right. It's really impossible to have infinite exponential growth.
Yeah.
It really is, right? At some point, something gets limited.
Yeah. Yeah.
Yeah. Okay.
Okay.
Let's hope the limit here stops, right? Because if the mosquitoes kept growing, the mosquitoes would there'd be more biomass in mosquitoes than people. Maybe there is more biomass in mosquitoes than
Yeah.
people, but I don't
Well,
think so.
with growth of populations, what happens is it grows. Yes, they do grow exponentially for a while, and then they reach the limits of the resources,
Right.
and yeah.
When I was
And
helping some kids with calculus last year, in the calculus book, when it talks about growth as this formula, I forgot. Do you remember the name of that formula? Someone's name.
Is it the logistics formula?
Yeah, maybe
Logistics
the
equation?
logistics formula, but it also has a
Yeah.
name, like the person who wrote it.
Yeah.
The logistics formula. So you'll
Yeah.
learn about it when you take calculus. You'll see how it works.
Mm.
It obviously has a minus sign in there because eventually something gets limited and something has to cut off. The growth can't cut off.
Okay,
I
great.
guess that's it, right?
That's it.
That's it for today. Okay, everyone, have a great day. Hope you like this, but still give us comments because we really need your comments, feedback to know how to improve what we're doing. Okay, everyone,
Yeah.
have a great day, and
Okay,
please
bye-bye.
send us comments to satmathquestionoftheday@gmail.com. Take care, everyone. Bye.
Bye.